Here at the University of Texas at Austin, they're working hard to put the human in humanoid robot. That's no easy task. Our minds and bodies are as complex as it gets.
Who's there?
But Professor Luis Santis and his team of students are giving it their best shot.
Hey, Luis, you have to tell me about this gorgeous creature that's here right now. What is this robot? I mean, like, I feel like I'm a kid again, straight out of Japanese anime.
Dreamer is a robot that is focused on the cooperation and collaboration with humans. And for that, we wanted to be friendly, and the look was very important.
If you're gonna work alongside a human, better to look like this than one of these faceless industrial robots.
They ultimately need to make you more productive, as we know from factories, but you need to be comfortable and you need to be able to express some sort of feelings or understand some sort of emotional cues from the robot.
People notice when the eyes are synthetic or animated, and it kind of creeps people out. This isn't creepy at all.
Yeah, absolutely, and we put a lot of effort in the eyes. After all, it's a mechanical device, and we figure out that there is a human feature called saccade, and it's the ability of moving the eyes very quick to look at things, and we endow these capabilities to this robot, making it much more friendly and comfortable.
Dreamer doesn't just look friendly, she feels like a buddy too. It's almost like her brain is processing human emotions in real time. And look, we're bonding.
We're moving towards what we call ethical robotics, moral robotics, and relationships of trust. And we're making an effort to actually computing all of these things with mathematics. So now it's possible to investigate those areas and endow some of the very human emotions into these sort of computational devices.
How does all that work with her brain? I mean, I'm looking at these wires and these processors. No offense, Dreamer, you look beautiful. But this is where all the computations are happening. Is that right?
That's right. Inside, if you open it up, it has a computational unit called an MCU. And that coordinates with the brain interface. The brain interface has much more access to all the kind of situational awareness, all the sensing of this room. And the coordination of the two is fundamentally important for a coordinated behavior.
Luis's ultimate goal is to have Dreamer work as a technological assistant. Kind of like a robotic butler that helps you with every tech-related task. That could be accessing email, checking on home security, or even monitoring big company data.
Also, ultimately, Dreamer could be a jack of all trades, being able to access whatever task she needs to do, just access that information from the cloud. Is that what you're working towards?
Yeah, absolutely. We're inching towards that capability.
Wow, Matt, are you ever? And I'm telling you, Dreamer was the perfect name for this robot because you can do anything you want to.
Luis and his team have knocked robotic facial construction out of the park. And now they're onto something even more challenging. Teaching this robot how to move with the swagger of a person.
So what kind of human movement are we talking about specifically here for this robot?
Well, in this case, is balance and is the ability of maneuvering over very complex terrain. And how can we use that for practical tasks, in particular for the Navy or for understanding human movement?
Considering how often I wipe out, this is definitely one area of research that I can get on board with. And it doesn't stop there. Luis has huge plans for this robot.
When we become old one day and we lose mobility, we can actually put on some exoskeleton and go off to the mountains with our kids.
So you're telling me that when I'm 70, I could put on an exoskeleton and do some American Ninja Warrior crazy flips and climbs?
Absolutely, that's my goal. That's what I want to do.
Before they can start on that, they'll spend several more years perfecting the joints that help this guy walk.
We have here 3 degrees of freedom, the knee, and then we have the hip flexion and the hip rotation as well. And then you can see also that we have these kind of human-like muscles. We call them electrical actuators. A muscle in this case becomes an electrical motor, and then we are driving a lot of the mechanics, and then we have these things that look like tendons. They store energy and they release it, allowing us to be very agile.
Where do you start with that? I mean, because walking, even though it's pretty simple for a lot of us, I mean, that's got to be a pretty complex thing to try to recreate.
We start with a real human, where we do motion capture of these kind of movements that are very difficult to achieve, and we capture the essential features. Sometimes we call them the key frames. And then we sort of formulate that as a mathematical problem. And then we endow it into this sort of machinery that we have back here.
But robotic engineering is more than just creating a product that looks nice. Engineers have to teach those bots how to behave nicely too. Because in order to work well together, there has to be trust.
Okay, Luis, I gotta admit, I was pretty stoked when you told me for the next demo I just have to kind of lay down and relax. But then I see a robot on wheels dangerously close to me. I'm a little nervous.
Well, I'm sorry, Lucas, but we're not going to play nice to you this time. We're going to actually throw you a 120-pound robot, so let's go ahead and release it.
Seriously? What have I gotten myself into?
We have this homemade robot just coming full speed to
That's
you. And
coming towards my face. That's coming towards my face.
Oh, God, thank you so much.
Wait, that didn't hurt at all. How is that possible?
So what was just happening there?
Well, what's happening is that we use a new technology that it consists of using these vibration sensors on the drivetrain of these wheels, and then we are triangulating, and we're finding where you are. We know exactly the direction where you are, we know the forces we're making on you, and then we have these controllers that provide safety warranties, and I think it's all about warranting your safety.
No kidding. If I'm chilling on the floor of a library reading a book, I need to be able to trust that a heavy surveillance robot won't accidentally crush me.
We're just talking about trust between a person and a robot. If I know that a robot can see me, and if it does hit me, it's just a little tap.
That's right, exactly. So we want to give you an assurance that this is safe, and we do that in various ways. One way is that we just move away from you as quickly as possible, but we also have to give you a sense of, why you're going to trust it. This guy, he does have technologies to provide 99.99% safety, which we believe is adequate for everyday environments.
It's absolutely amazing, but you do realize when I tell this story to my friends that a 120-pound robot hit me and I just walked away from it, right?